Hey everybody, I'm back and we're going to be talking about cooling systems in this segment of videos. We should have four of them this week. One covering coolant, which was my previous video. Then this is going to be on the cooling system. And the cooling system is very critical and when it comes to your vehicle, and how it works is kind of common, but there can be some different types of systems. So what I'm going to do is go ahead and start my share on this, and we'll start it up in just now. So cooling systems, we're going to be talking about the operation, and also we'll talk a little bit about the easy, quick diagnosis that you can actually do yourself. Uh, some of them you can actually do the repairs. I'm sure all of you can do all kinds of repairs on the cooling system. It's a lot of it's just removing bolts and stuff like that, but there are some unique tools you might need to do on some of the cooling systems. Now, the coolant, as we learned before in the last segment, we talked about its properties and how it absorbs the ethylene glycol, where the coolant part can actually absorb heat, whereas the water helps kind of dissipate or expel the heat. And we're going to kind of wrap that all up into this part right here. So here is what's going on. So in the engine, we're taking chemical energy and creating mechanical energy. And how we do that is we actually take that chemical of air and fuel, and we burn it, and creating a high pressure in a container in which moves that piston around. But when we do that, we're actually creating heat. And if we continue to just heat, we can actually start melting pieces, causing harm to the engine. So we need to get rid of that somehow. And how we do this is through the cooling system. So the coolant is kind of part of this whole process. And here you can see that we can actually have about 4,500 degrees Fahrenheit inside that combustion chamber, which it can melt, metals and cause, failure. So what we have inside the cylinder heads and also in the blocks is passages. These passages are strictly for the coolant, and they fill up, they're actually submersed, I should say, they're full of coolant. And this coolant is what actually takes the heat away. It kind of pulls the heat away because of the ethylene glycol properties. And then we actually circulate it through the system. So you can see right here in this picture right here, is creating heat. Here are my coolant passages. So coolant is floating down here. And this is just a pictorial. So there are different setups as we go along. When you get into your engines classes, they go deeper into the cooling system passages. You actually, if you get into the rebuilding class, you actually get to see them. And this is all very, very critical. And here, one of the things when they cast the engine blocks, there has to be some way of getting rid of the sand. Basically, they do forms in it, and they shape this sand that would be in the cooling system passages area, and these what they call core plugs. So sometimes people call them freeze plugs, but these casting plugs are what are actually circular places that actually are left open so they can actually shake and blow all the sand out of it as they go along. So here again is the same setup we had before, and you can see all the coolant is down inside these passages. This is a good picture of how the cooling system actually moves this coolant around. So what you see here is, the fan is, they're showing a fan in front of the radiator. So the radiator, what it does in the cooling system, and it actually allows it to give off the heat. And we take coolant across this radiator. I'm going to have some pictures in just a minute on showing you how that happens. But just follow with me here. So I have coolant in these little coolant passages. Here's my engine, and it looks like it's going through the engine. It's not. It's actually the surface areas around the inside. It's just not a very good picture of it. But down here is actually what they call a water pump. This water pump is the circulating part. This actually causes the coolant to move around, is what it does. This is what builds up that pressure to actually cause it to circulate and on through. We also have a controlling device called a thermostat. Now, one of the things that we want in the cooling system is to bring it up to operating temperature as quick as possible and maintain it. If we don't, and we allow it to continue to rise, which can happen with a failure in the thermostat, is then we actually cause failure in engine parts. Whereas if we control it, we're bringing it up to operating temperature, which then you get better gas mileage and also better emissions, fuel emissions like that. In the later part of this semester, we'll talk a little bit about emissions and stuff like that. But we need to get it up to temperature as quick as possible, and then we need to continue to hold it at that temperature as close as possible. And we do that with that thermostat. Now, that thermostat is one of the critical parts of it. Back here, you'll see this little pipe down here. Well, this is actually going to the heater core. So it actually supports the actual, the heating part of your vehicle too. So when it's cold, we can actually blow air across this heater core, which looks similar to a radiator, and it can actually warm up the passenger compartment is what we do. So, but we get the coolant going across here, and we take this surface area of this radiator and we blow air across it, and this is what causes it to get rid of the heat. So again, if we had 100% of coolant, we would just be holding on to it, and it'd be kind of difficult to get that heat off it. It would give a little bit off, but it wouldn't give that that much. So what we do is add that water, or that distilled water, and cause it to actually get rid of it, let it go, kind of thing like that. This is a thermostat. This is what it's built like. Inside here, there's a little pellet area. This wax pellet allows when it gets cool, it'll actually close. When it warms up, it'll actually allow that spring to overtake and cause it to open. So they're going to go back and forth, back and forth. So there's this little valve here is going to open and close. As you can see here, this is when the cooling system is not warm enough yet. So it's going to allow it to trap the coolant and allow it to circulate through this bypass. And then when it gets warm enough, it's going to allow this to unseat, and it's going to allow coolant to go up to either through the lower radiator hose or the upper radiator hose, depending on if you have a conventional flow or a reverse flow system. And this is what actually causes to allow that coolant to go across to the radiator, and now the radiator will allow it to get rid of the heat. So depending on the manufacturer, this is critical too, that thermostat is calibrated. Now, this cooling system thermostat is a program to open up at different temperatures depending on the manufacturer. Two of the most common is 180 and 195. And this, please make sure you put the right one in your vehicle or your customer's vehicle. You can actually cause problems either with emissions and mileage, or you may even have an overheating type problem arise if you put the wrong one in. So here is just showing that when the thermostat starts opening. So here it starts opening at 180, and it's kind of goes up to 200 when it actually that valve is fully open. This is going to slam. It's opened up. It takes its time and then opens up that way. This other one starts up at 195 and goes up to 215. So this is where we're going to get into a little bit more. Wait a minute, 215, Marty, didn't you just tell me at 212 it starts boiling? You remember we had the coolant in there, so that helps raise the boiling point. So now we don't start boiling at that lower level. We have a little bit of comfort room there. Okay. And then here's a thermostat that failed on us. So this is stuck open. This has not been heated or anything like that. It's just wide open. And this would cause a system stays cool too long, you might, mostly we would get a complaint that, hey, my heater doesn't work in my car. And that's one of the first signs. Or, hey, my gas mileage went down. Or, hey, I couldn't pass my smog test because, I don't know, can you help me out? It's usually because we didn't get warm enough for the system to work. This is where the thermostat is on some vehicles. Some of them are lower. This is actually on top. And this has got a thermostat housing. This guy right here is the housing that holds it. This is a cutaway. And here's one style thermostat. So this would open up and allow it to flow through this direction here. And some of the thermostats actually have an electronic part of it, and actually will use that to actually cause this, the thermostat to open, kind of giving it a little boost and stuff like that. And it's controlled by a computer. So one of the things that we can do with the cars with computers is actually monitor the cooling system temperature, which is a great tool for figuring out if it's got a cooling system problem too. You can actually put up a scan tool and pull up this PID, as they call it, and look at the data across. So you can see right now it's at 194 degrees Fahrenheit. So that would be acceptable. Actually, it's a little, I would say, if I was looking and it was totally warmed up as far as it can, I would say there's actually probably a problem. I see a bigger problem right here. The ambient temperature outside at negative 36 degrees. Ooh, that's a little bit cold. So either it's back east or we have a fault going on here just by looking at this data. Some of the thermostats are integral to the thermostat housing. Some are, like the previous ones, were replaceable. You just take that little guy out. They're about maybe 10 bucks, maybe cheaper. This one's going to be more expensive. You're going to probably talk about 60 or maybe even $100 of thermostat, and that's where it can get kind of expensive. This is the radiator, and this is a kind of a picture of what the radiator looks like. Now, it's exactly like this. This is on this particular one is a downdraft, and it's a downfill, I should say. And these little tubes, and you can see these fins attached to it too. So the tubes go straight down. These little fins are cooling fins, and heat can get released through several sources. One of the things is with the fins, it actually takes the heat away, away a little more uniformly. And if we blow air across it, it takes more of the heat away. So the tubes are connected to fins, and these fins actually, because they're touching, they can actually help get rid of the heat. So here is a couple different types of radiators. We have one is a down flow, and this is a cross flow. Cross flows are probably going to be more your popular ones. The down flows are pretty much more so in early days, and this one is a little more efficient. Now, one of the things that goes inside the radiator a lot of times is a transmission cooler. If you have an automatic transmission, they'll put an transmission cooler inside. Transmission create quite a bit of heat. And again, we can have breakdown in parts if we don't get rid of the heat. And this is just, through actually the flow of cooling across it, it can help take away that heat also. And here's another picture of a transmission cooler, that goes across. So these would be connected to the transmission lines back to the actual transmission, and that would circulate some of the transmission fluid through this little chamber here. Now, if this chamber ruptures at any time, it's a mess, folks. It is, and it can cause detrimental effects to everything. Through the cooling system now, it's got oil, and oil does not release heat as that well, and if it gets water in the transmission fluid, then you're talking clutch material going away also. So it usually, if you take off the cap, when it's cold, when the cooling system is cold, and you see almost like a milkshake affair, then and I'm talking about a strawberry milkshake, because most of the transmission fluids are a reddish color for identification, and then you've got an actual, actually that little cooler has actually been ruptured. So this is, we're going to talk a little bit about how, the other thing that we do to assist in keeping down that boiling point. Now this is, we use a radiator cap. The radiator cap, not only does it keep the fluid in there and just keep it contained, it also builds up pressure. So for every pound of pressure on that cap, we have 3 degrees of actual, we can actually raise the boiling point. So with the coolant and also with the pressure cap, we can considerably raise that boiling point so it doesn't boil into a very high pressure. So let's say we have a 16-pound radiator cap. That's about 48 degrees that we can raise before water boils. So you were talking about the 260 area. Okay, most of the cooling systems will not get up to 260. We, like I say, some of them will go up to 230, 235, but not the 260. So we don't have that fear of boil. This is the caution part. Do not take the radiator cap off when it's hot. If you take it off, all that pressure is going to come and try to escape, and it's usually going to be on you. And that can cause 2nd and 3rd degree burns, and it's very, very painful. I've had radiator hoses, doesn't happen very often, but I've been in the field for quite a while. I actually have a radiator hose explode. The internal parts of that radiator hose actually, it's the rubber parts that actually get the inner wall breaks, and then fluid can actually escape, and it sprayed a little bit on me. It was very, very painful. So you want to be very careful on this. So here is kind of the, what we're showing here is pounds per square inch, which is pretty much what we do radiator caps in the US, but you can actually have bar, and this is another measurement in a metric. So we can have a standard measurement or a metric measurement. So this is the equivalent. So if you see a radiator cap on a, let's say a Toyota or a Mercedes-Benz or something, you might see like 1 bar that tells you it's a 15-pound cap, or you might have a 1.1, it's a 16-pound cap. So this is what that's actually showing. And here's the radiator cap, and then it has 2 sections to it. It has a pressure section and a vacuum section. And why we do this is liquid, as it is heated up, it expands, okay? And same thing happens with coolant. And we need to actually capture that coolant. So we're gonna put it into a reservoir. So when the coolant is actually, when we get to where the coolant expands, if we don't have it someplace to go, it's going to start blowing connections. You will have radiator hoses, pop on it. You'll have, other things that can go bad on it. Wherever it can escape, at the weakest point, it's going to try to escape. So what we do is we have coolant into an overflow bottle or a surge tank or a overflow bottle, like I said before, and that actually allows the expanded fluid. So in your overflow or your surge tank, you're going to see it rise and fall. Well, when it's hot, you should see it go up almost to what they call the full level. And when it gets cold, it's going to go to like a minimum level. So when the coolant starts cooling down, it's going to contract. So it's going to kind of squeeze in. And now we need to get that coolant that we actually, when expanded, back into the cooling system. And how we do that is through the suction side. This little center section, when it actually feels a little bit of pressure drop or suction, it'll open up and allow the coolant to come down inside the expanded coolant, which is contracting out, to come back down into the radiator. And one of the quick things I want to point out is that surge tank. Hopefully I'll have another, this little overflow bottle or a surge tank. You should see it rise and fall. If it doesn't, you may have a bad radiator cap. The radiator caps, again, are fairly inexpensive. Only take them off when the cooling system's cooled down. And here is a good example right here. So it says right here full, and this is going to be full one hot. Okay. And if it's down below that, you probably got a leak someplace. You need to kind of identify where that actual fluid is going. If it's overflow and you're going above, you got too much in it. And the other part too is if it stays here all the time, and when it's hot or it's cold, you probably got a radiator cap that's bad on it. It's not allowed, that suction side is not working anymore. So you may be low on coolant inside the radiator itself. All right, so, and here, I talked about that. So here's a surge tank, like I talked about earlier, and it's just, now it has a closed system. There's no radiator cap on the radiator. It's actually on the surge tank itself. Water pump, it's like I said before, it circulates all the coolant through the system, and this has little fins in it, and that fins kind of allows it to push that coolant around. It'll come, kind of come in from the bottom hose here, pull on through and circulate it through the different sections of the actual water pump, causing it to force it through the engine coolant passages. This is showing how much coolant does circulate. It's quite a bit. You can see by this demonstration actually here. It's actually got a little V8 engine over here. And this is what can happen with a poor cooling system. This, I've actually had this happen to me before. I got a complaint from a customer that it was overheating, and it didn't take very long for it to overheat. They had been neglecting cooling system on it. And instead of little kind of like, let's put it this way, there is an actual almost a 45 up a piece of metal that's supposed to be there. And this metal is supposed to paddle it around. Right now, this is corroded all the way, kind of rusted away over a period of time. And now all it does is chop through the water. It doesn't push it, it just chops through it. And this is not from overnight. This has been for a long time that this has been going on. So this has probably had 100% water in it, and no corrosion fighters or anything like that, like coolant or the ethylene glycol with the additives will resist the amount of rust and corrosion that can happen. So it's very important. That's why I'm saying it's very important. This actually says right here, blew ahead, guys. I can see that happening. This is just one of the things I want to point out. One of the quick identifications if a water pump's starting to leak, there's a little weep hole. This is kind of a little chamber for the bearing. There's a bearing inside that water pump that keeps it quiet. If there's in a few seals, if the seal which can happen after a period of time, especially when the cooling system hasn't been taken care of, that seal can actually cause a little bit of a leak. The first place it's going to go, because the bearings are above this, and that weep hole will kind of let that coolant drain through. If you see trailing or any kind of fluid coming out of here, that water pump is time to change. Here's a cutaway of that. So back here, like I said, here's that seal I was talking about. And they're usually one seal, two seals, and then there's a bearing right here that actually keeps that shaft straight, and that causes it to actually, and then you'll have either a hub or a pulley affair up here to actually make that work. So that weep hole is what I was showing you just a few minutes ago. So here's a seal here and a seal here, and then that bearing. All right, so here is another kind of picture of actually a water flow, and this has a cross flow radiator. Like I said before, here's that reservoir tank. Here's a radiator hose, lower radiator hose, it's rubber, and here's the upper radiator hose is this rubber too. They put rubber hoses on it because the engine does flex. If it had solid, it would break the connections like that. And then here's your cylinder heads. Oh, this is a V-type motor here, and it actually goes through these little passages. Remember, it's not filling up the engine with coolant, only in the passage area, okay? And if we do get coolant inside the oil, and it can be ill effect from gaskets leaking, possible cylinder head crack going on, Very rarely does it actually block leak, but it can happen too. All right, so here's the actual coolant passages that you could see when you tear an engine apart. A little bit of a gassing vent here, so keep pressure off a little bit on it too. This is a V8 block on one side of it here too. Radiator fans, here's the radiator itself. This one's showing behind instead of the picture showing it in front. You can have front or back. You can have a push fan or a pull fan. This is a pull fan. It's going to pull air across, and these are electric on this particular one. You can have the old mechanical ones, fans, but it's not as popular because electric fans are more efficient. And here's an old mechanical fan. These had ill effects. You can actually see right here, the plastic would break after a period of time of in service. And here's cracking right here too. So these are all things that can happen. This has an actual bimetal spring on it, thermostatic spring, I should say. And as it gets heated up, it will actually move and lock that fan into the actual pull. When it's cold, it allows that fan to freewheel. Okay. Here's a heater core. This is going to be inside the vehicle, or it may be on the outside, but usually it's on the inside. And this heater core goes through some air ducting, and when you turn on the heat, which causes the heat to come inside the actual car itself. This is a bad radiator. If you see traces like this, or this has actually been hit a few times too. Like I said, these fins are very critical for dissipating heat, and you can see how they're all kind of smashed together. This is not going to get rid of the heat as efficiently. You can't get air to actually flow across here. So this is one of the things that we look at. And when we do our visual inspections, we look at the integrity of the actual radiator and see if it's been hit by rocks or anything like that. And also, we look at the fins. Now, sometimes you can take what they call a fin comb. It actually looks like a hair comb, but it's all made for fins, and you can straighten a lot of this stuff out. But I would say this one is a pretty bad shape. It's actually showing some greenage going on, and that means more likely we have a little bit of a leak from the core. This is considered a radiator core, and then you have a couple of tanks on the sides or the top and bottom to actually hold everything in place. One of the tests we do to check for leaks is pressurize the system, just like the radiator cap does. And we have a device that actually, cooling system pressure gauge, and we pressurize that up by actually moving it. And here's that pressure gauge, and then we're checking the cap too. So we can check the cap. The only part we can't check is the vacuum part of it, but we can actually take the cap and pull on the vacuum valve, see if it actually moves. If it's stuck down or it doesn't want to come down, then we know we got a bad vacuum side of it. And again, that's nothing you can do. It's just change the cap out. One of the things, if we find that we can't figure out where the leak is at, well, we can actually put dyes in the cooling system and look with a black light to see if trails of any kind. We usually have to run it for a while, and we put the dye in, and this is just one style. This is done by GM's Goodwrench program, but you can still, you can find other dyes out there too. And here we have an actual overheat. You can actually see steam going on. So this is actually not a good thing. So, you definitely do not want the vehicle to overheat. If you do, one of the tricks I have for you, and this is if you're out and about and it starts to show, if you have a temperature gauge, it starts to show temperature counting, like getting to that 250-ish type area, then what you can do for a quick right now and get to someplace to have it serviced, or you service it yourself, is turn on your heater. Your heater is another device that can pull off heat. Okay, if you have coolant in the system, it will actually cause it to help pull some of that heat. Yes, it gets very warm, especially when you got a hot day like it's been, but you can actually possibly save your vehicle from overheating even farther. Get to a safe spot to let it cool down, and then kind of inspect and see what's causing it. Maybe you got a coolant leak, maybe you have a thermostat stuck. So these things can be checked. And this is on, the actual serpentine type belts. One of the things we do for moving the water pump is through belts. And these belts are little rubber pieces that move around a set of pulleys and actually spin that water pump. So here's a tensioner that keeps automatic tensioner on that belt. If we allow the belts to be too loose, it's just going to slip. We're not going to allow it to spin that water pump. Some systems actually have a bleed part when you start to fill up the cooling system, and you'll need to actually open up that bleed valve. Again, when you start getting into more your upper level classes, you're going to start talking more of this like your engines classes and your your auto maintenance classes like that. All right, and this is a recycling machine. Instead of just throwing your coolant away or disposing of it, you can actually go through a recycling process. Now, only I would say only a certain amount of shops have this, and this is one of the fluid exchange programs you can actually do on your vehicle. And you have different types of clamps for the rubber hoses that are on the vehicle, and this is the you put the hose over a metal piece or aluminum piece, and then you clamp it on there, and that seals the actual from leaking out, the coolant from leaking out. And different types of hoses. This is a, this one is a similar to coolant, but it's actually, some are actually for different types of liquids like radiator fluids. Some are for fuel. Some of them are actually for like transmission fluids and stuff like that too. All right, so this is a little bit about cooling systems, and this is, we'll be getting into engine oil in our next little video section. So I will see you soon. Hopefully this is beneficial. And again, coolant is a big part of it, and the coolant helps the cooling system keep lubricated, keeps it from rusting. Anti-foamers are in it also. Depending on what your makeup of your vehicle is, the coolant you need to have in it. And also the cooling system is what helps circulate the actual coolant through to help dissipate the heat. So this is the key parts of it. The cooling system gets rid of it, and we do it through a water pump, so through some piping through the radiator, and some absorption from the inside the engine by moving coolant across coolant passages in the engine area to actually take that away. All right, I will be talking to you soon. Take care.